Okay, page 2 here, we have the vertical angle theorem. If two angles are vertical, they are congruent. Okay, so I'm going to just draw this up here for picture purposes. We're going to say this is angle A, B, C, and D. Right? Okay, so proofs. We start out here. We've got our T. We have our statements. And we have our reasons. What do we know about this already? Well, we know that angle A and B, angle A plus angle B is equal to 180 degrees. How do I know that they're equal to 180 degrees? If you notice these two angles, they are a linear pair, right? And the linear pair postulate, so I'm going to put this here, linear pair postulate on the previous page told us that any set of linear pair angles are equal to 180 degrees. So we have our first part of our proof written down. What do we also know? We know the angle B plus C, okay, angle B plus angle C is equal to 180 degrees. Okay, why? Because also the linear pair postulate. So I'm going to just put it like that. So from here we can say angle A plus angle B is equal to angle B plus angle C. Why? Because we're using the substitution property. What we did here is we substituted this 180 degrees out for what this 180 degrees was equal to. We substituted that in there. Okay, now we can subtract angle B out of each of those, and we end up with angle A is equal to angle C. And we did that by the subtraction property. Up above, this was a substitution property. I guess I need to write a little bit more there. Subtraction property. And right here, those two are vertical angles. So we just went through and proved them. What did we have to know? We knew that angle A and angle C were vertical angles. That's what we had given to us. Angle A and angle C were vertical angles. I just forgot to put that at the top. Okay, corresponding angle postulate, I went ahead and typed that in here. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. We talked about that on the previous page. We had our two parallel lines like this. It's cut by a transversal. Corresponding angles, that would be such as this angle right here and this one right here. They're both on the bottom right side. Those would be corresponding angles, and they are congruent to each other. Okay, doesn't matter where they are, as long as they're corresponding, they are congruent. Next, we have the congruent supplements theorem. What it is if we have two angles or supplements of the same angle, then the two angles are congruent to each other. An example of that would be if we have, here's angle 1, and so angle 2 would be this right here. These two angles are supplements to each other, right? And angle 3 is also a supplement to angle 1 because these two angles, number 2 and 3, are both supplements to 1. They have to be congruent to each other. That's the only thing it's telling us. So the next one, congruence complements theorem, it's pretty much the exact same thing as above, like that, except it's complementary instead of supplementary, but it repeats, okay? So it's the same thing. If they're complementary, if you have two angles that are complements to another angle, then the two angles are congruent to each other. Next is our alternate interior angle theorem. It says when we have two parallel lines that are cut by a transversal and the resulting alternate interior angles or alternate exterior angles are congruent. We're just really working with the alternate interior on this one. Alternate exterior will be this one right here. But we need to be able to prove that. Some of these proofs will be a lot easier than other proofs. Okay, so we're going to call this angle L and angle M here. We know that angle L is parallel to angle M, and that is given to us. Anytime you have those two little lines like this, two lines, that means L is parallel to M. That's what it's standing for. Okay, so since those two lines are parallel to each other, we know that angle 2 is congruent to angle 4 because of the vertical angle theorem. Okay, I'm going to highlight them in green when we know that they are equal to each other. We know 2 and 4 are equal to each other, or congruent to each other. We know that angle 2 also is congruent to angle 6 because they are corresponding angle theorem. That was the one that we did up here, corresponding angles. Corresponding angles would be in the same location. So angle 2 is equal to angle 6. Now because of what we have here, you can look at this. Angle 2 is congruent to 4 and 2 is congruent to 6. So we could use transitive and get rid of the angle 2's and say angle 4 is congruent to angle 6 by the transitive property. That's one of our algebraic properties. And if you notice on here, angle 4 and angle 6 are alternate interior angles, so we proved it. Okay, next one is just kind of a repeat of the last time. You'll look at our alternate exterior angle theorem when two parallel lines are cut by a transversal, and then the alternate exterior angles are congruent. We're going to just use this again, what we already have. We know that it is parallel lines. Okay, so I'm going to put statements here and our reasons here. We know that angle L is parallel to angle M because that's given to us. Why is it given? Because it tells us that it is two parallel lines. So we know that they're parallel. And this time for my highlighter, I'm going to use red instead of the green. Okay, what do we also know on this one? We know that angle 2 is congruent to angle 4 because they're vertical angle theorem. Okay, so that would be 2 and 4. We know angle 4 is congruent to angle 8 because angle 4 and angle 8, if you can look at those two, they're corresponding. They're in the same location, so corresponding. Angle postulate. And now we have, from there, we can use transitive, get rid of our angle 2's, just like we did in our syllogisms. Angle 2 is congruent to angle 8 through transitive property. And as you can see, angle 2 and angle 8 are alternate exterior angles, and so they are congruent to each other, and we proved it.